So welcome everyone to the Forth 2020 Zoom meeting in April 2022. So we have a very good schedule of talks today. And so let's see, without further ado, Scott McCallum wants to talk about his forth to the power of 3. And give us some demonstration. So, Scott, are you ready to present?
I do believe so.
Yeah, then please share your screen so that we can see it. Yeah, we see some green, large and small letters. The stage is yours.
Rightio then. Well, my name's Scott McCallum. I'm actually a software developer coming up for probably 40 years now. So I got started when I was 8 and we sort of hit the big 50 this year. I've always had an interest in programming, and for the last 25 years, I've been working for myself with an enterprise product to manage disk space. But over the last 5 years, I've been sort of in a bit of a pivoting mode, and I'm building an asset exchange. So an asset exchange that can exchange non-fungible assets. So things like movie tickets and doctor's appointments and other types of things that have a heap of properties associated with them. So the reason I'm investigating Forths is that I needed a sandboxable language that you would actually write your orders in. So you might be familiar with a stock exchange where you basically say, this is the stock code I want, this is the price, and this is the quantity. And generally, you've then got a small series of other properties that you can go along with it. But it's not programmable in any sense. So I'm building a system where the buy and sell orders are Forth programs. And these Forth programs, in effect, are sorted, and they actually figure out whether the thing that you're purchasing is available, can I get it for the price I want? And if so, it actually makes it happen. This thing is being developed in Python. And so I ended up looking around for Forths that run under Python. And the only other major one that I came across was RetroForth, which is available in a whole heap of platforms. Because RetroForth is at its core, its cells are integers. It's a sort of, there's a bit of an impedance mismatch between Python and RetroForth. RetroForth works, but Python, it just sees crazy numbers all over the place. You can't take advantage of the Python objects. So I ended up embarking on developing my own Forth, and I called it CUBEDForth. And in CUBEDForth, the cells are actually Python objects. So I can go across and type something like hello world and put a plus at the end of that, and it's concatenated 2 strings for me. So it's nice that things like string management are really quite simple to actually work with RetroForth. It's got a mode where it actually understands JSON. So Scott was here. That also works. Now that looks like a comment, but basically where the next character after an open brace is either a quote or it is a brace, you can actually start putting in JSON structures, which is handy because I need to be able to match against these structures. So that will actually create a Python dictionary on the stack. So I've got a couple of, I've basically listed a whole heap of these commands that I think are interesting in the Forth, and I'm just going to run through a couple of them. So we've seen the string uses that single quote as it's starting off, which is what RetroForth used. I've also got in there the ability to do multi-line strings. 1, 2, 3, 4, and close that string off. And you can actually see there that the string's got a carriage return character in it. So it actually supports multi-line strings, because if you do any sort of Python work, multi-line strings are just natural. And I'm basically building up bigger things with this. So that's the multi-line strings working. If I get rid of the things off the stack, oops, excuse my, so at the moment, if it gets an error, it actually brings the exception all the way up just for debugging purposes. Because this is an object, I can, again, using the, if it's a brace and a dot, it actually says, okay, you want to call a method on the object, on the stack. So I can go replace, and I'm going to replace L with X. And you can do string matching type stuff. And this really means that the speed of the Python interpreter, because we're dealing with native Python objects, is actually really, really fast. It's very performant. Some of the raw tests put it as an equal speed to RetroForth for simple things. But as soon as you start getting more complex stuff, it really comes into its own. So I can do things like with my string here, 1 cat 2. So that's a string, 1 cat 2. I've got JSON load, and it didn't like that. Where are we? 1 cat 2. I didn't close that dictionary list off. So that's given me a Python dictionary. Because memory in this thing is actually a Python dictionary, I can actually say foo bar and actually go store that in memory. If I type mem, my memory, as far as the memory of the system is concerned, it's dictionary. I can actually use strings or I can use integers with this. So it has all the standard here type notations for memory and growing memory and that sort of thing. But I'm finding with the programs that I'm writing with CUBEDForth, I don't tend to use the forth variable declarations. I just store them directly in the dictionary under the variable strings, which is handy for that. Memory, so we've seen memory. If I do things like C here, and C shows you the definitions of the words, it actually comes back with the underlying Python implementation and gives you the actual Python bytecodes that represent that method. It's interesting because the actual words are defined in the, where are we? The words are defined. So here's the, so we've got word T left brace. So it actually uses Python introspection of the method names to actually figure out what is the actual underlying forth name for that thing. So I've got T brace exclamation mark, which was basically doing knots and things like that. So I'm playing around with some of these things. But there's basically, we've got words. So it's a fairly complete implementation. I've got it down so there's probably half a dozen tests that aren't currently working, and the tests, stop, tests. So it's using that the John Hayes testing library. And there's certainly some things that I don't need to test, and that's particularly got to do with the integer support. Because if you do crazy things like 232 to the power of, you get your 4096. So if you only had basic integers, then that's you know, where they start to top out. But we can go 4096. Because it uses the Python infinite precision number libraries, which basically means that, yeah, you can go to town on these things. I've actually, in the sandbox, got to put restrictions on the numbers because you can basically create crazy numbers and crash the sandbox on that side. So I've got to put some controls on just how crazy you can go with those numbers. Because clearly it's quite easy to raise that to itself, and all of a sudden you've got a 1,000,000-digit number coming out of Python, which is sort of interesting. It supports things like 5 plus for J, minus 1 minus 1J, and add them together. And we can see over there we've got 4 plus 3J, so it supports the complex numbers as well. And again, this is all freebies that you get out of Python as an underlying object system, which is handy. So I've got things like, I had my JSON load up here somewhere, JSON load. I can do things like do v print it loop.
That loads
Oh,
it.
no, I've forgotten the
close square
the
bracket.
close brace. So that's actually looped over the things. So again, that supports the Python iteration type of objects, which is handy. I can also do interesting things like this, which is say x times 3, t times 3, and that's lambda, lambda. So if we go c times 3, that's actually a Python function. So I can go 3 times 3, and I get 9 back. So it's quite handy. So you can actually just put little Python snippets in there. So you don't need to always go into the actual interpreter. Now in the sandbox, clearly it's not going to allow things like lambdas to come out of it. You can also do things like, if we do our double strings, def word foobar, and it takes 3 parameters, and 1, 2, 3, 4, return foobar, and that close the string off, and say that's Python. Okay, so now if I do foobar, I should get back a capital foobar. So you can basically define blocks of Python code and actually turn them into a function and then manipulate them in Forth, which is handy. So things like if I do, it's single quote and then times 3, that actually brings up the that's the execution token as far as this thing's concerned. It's a Python tuple with a function pointer in it. So I can then go 3, well, no, we'll go 33 swap and 33 swap and execute. I get 99. So it basically, yeah, so the quote pulls the execution token off, executes it, but it's just as if I had have written as 1, 2, 3. And if I want to see Baz, I see Baz, I get 1, 2, 3. The execution token for Baz is actually just a list. So you can actually create your own functions in code and actually make them run if you like. And I had one more demo. What is it? So by doing the, how am I going for time? I've got 3 minutes. All right. Hello world. So that will create me a dictionary on the stack. I can then go world, no, so I need hello is the key, and stack at. So that actually is a method that says, okay, the key is on the top of the stack, pull the, go to the object that's under that and pull out whatever hello is. So when that happens, you find it actually leaves the hello world on the stack. So I found that working with these objects, the standard Forth idiom that it always absorbs the arguments isn't helpful because it was destroying the object all the time. And I'm trying to call multiple methods on the same object. So I was ending up with a lot of dupes all over the place. So I don't know if I've committed sort of huge crimes in going down this path, but to get around that, I have basically all the operators have one with the minus at the end of it, and that actually absorbs the actual object. So then I just get world out. All right, so that's me yapping for 13 minutes. Is there any questions about Python implementations? So yeah, so you've got all things like the table of all the symbols to what they actually map to in Forth. Add word, add sigil, import. And the actual execution loop of it is actually quite small because it's execute guards. Yeah, so obviously Python's a pretty cool language for doing this sort of manipulation and things in it. So yeah, it's I'd say it's 80% of the way to in fact it's probably 90% of the way. There's a few edge cases, but because of my application for it, I don't need backwards compatibility with these Forths. I just need something that's extremely bulletproof, and that's what I've tried to build with this CUBEDForth. So that would be my, yeah.
So you showed JSON objects, and
Yep.
you showed store. You use store to put the value into a JSON key.
Yep.
So can you show us some other interesting things you can do with the JSON objects themselves?
Yeah. So the so in this case, in memory, I've got a foo. So the foo memory location contains a JSON object, which is a dictionary on that sort of things. Now there's operators that I've got that you can do things like foo, and then you do that and at. Is it? Now this is where I haven't written this stuff down, and I'm not saying I'm super rusty on it, but I'm a little rusty. There's JSON load, there's JSON save, there's the standard ones. So if I pull that out of memory, so that puts it on the stack. I've then got the s at, and that would actually do world, but there should be the opposite of that. So if I put 55 and we'll go stack save, no, that's not going to work. I will have a look at object list. That's the handy thing with Python. These doc strings act as blocks of code, and these are the sanity checks that the interpreter runs on startup. So yeah, I'm playing around with getting things like in the Python structures. So I've overridden what a colon is capable of doing and moved the square brackets, which is the immediate code, to immediate. So immediate becomes that, because in my coding, I don't use that very often. Yet indexing into objects is something that you do. 99 length. So where do I use that? I'm just trying to think of the best place to show you that JSON stuff. But there's enough access things that a couple of things on the stack, and you can get access to the complex JSON objects. And I've been using it to do some testing.
Thanks, Scott. That's really interesting.
Yeah, so you can dig it. It's MIT license sitting on GitHub.
Mm-hmm.
So, and the CUBEDForth, and at the moment there's what we got. So there's my long-term support trunk, which is when I get something I'm happy with, I push it to that. Trunk 20 is what we're working on at the moment. I suspect in another couple of months I'll be pushing this trunk 2 back to here and calling it version 3 that we're working on. I'm mucking around with documentation and things like that for it at the moment. But yeah, no, I found it really interesting. I'm really happy with it. I conceptually, I know that this is a very contained piece of the bigger picture in terms of, because the exchange takes in from the public these programs and runs them against each other. And I need to make sure that, you know, it's not a gaping hole in security sense. Mm-hmm. And I'm happy that actually works with that. So yeah.
Yeah, so Dimitri had a question.
First of all, I think this is actually a really good use of Forth and Python. I was working on something a lot like this, but it was actually for generating hardware, like a kind of Forth implemented in Python, and you can generate Verilog from that. So I think it's good to combine the two together. But one question I have as a Python programmer is, can you make use of double underscore methods in this
sure.
implementation? You can.
Yeah, that when I called, what was it? So I was doing things like hello dot. If you do double underscore foo there, then you've just called a double underscore method. You know, get at her, that type of stuff. And then you can pass in a string to get at her on hello, but that won't work. Yeah, that should actually work. If we put in a hello, we'll try a double underscore as a hello world. So that's my JSON object. I can then call dot. Is it get? It's get item, isn't it? Get item hello. Didn't like that one. Get item.
Do you need to do a JSON load there?
I've done that the wrong way around. That's all. Yep. So that's called double underscore. That's the dictionary magic to do a dictionary lookup on that. And yeah, so that'll work. Obviously, in my sandboxed world, you're not allowed to do that because that's asking for trouble. But as for writing general purpose stuff, it's good. So, but I found with the testing code that I'm writing in the bigger system, I'm actually writing it in CUBEDForth because it's just easy to manipulate stuff. It's actually a lot more compact than Python. Yeah, so it's worth. I found it valuable.
Yeah, Scott, thank you very much. Are there any additional questions? I'm also the clock guard.
While the answer was being given there. So
Yeah.
I missed it, but I can always review that in the recording.
Yeah, okay, sure.
I'm sure I'm certainly happy to answer questions or yeah, or put a questions on the GitHub under the questions there. If you've got anything, I'm happy to. Yeah, cool.
Okay, yeah, thanks. Very interesting, and especially using Forth-like structures as a glue language for some other and inherit all the capabilities of the other languages.